Let's talk about compute and cloud. Compute is a generic term. I'll explain that term first and then we'll go into service specifics that how AWS implements compute. So as I said, compute is a generic term used to reference processing power plus networking, plus memory, plus storage, and maybe any other resources which may be required. So whenever we have a code to run something to process, that's where compute come into picture. Most of the time we relate only two terms with that, CPU and memory or RAM, but it could be something else too. Maybe we need networking also to communicate. Maybe we need a GPU, which stand for graphic processing unit. Maybe we are processing some workload or processing some data which require this capability. So that would also be included into a compute. Compute can be provided in a virtual fashion or in a physical fashion. We'll talk about that, what is a physical server versus a virtual machine in a minute. But idea is we need the processing power so that we could process some data and perform some compute operations on top of it. Now, first let's talk about physical versus virtual server. If I'm talking about a traditional approach before data center became virtualized, a traditional approach was you would have a physical server in your data center in your server rack, and you would have a operating system running on top of it, Windows, Linux, Solaris, whatever you are want to run. And once this operating system is ready, you would then host your application, which may be developed into Java, .NET, PHP, Python, whatever it is. This was a good approach for a long length of time, but what started happening that the server became powerful and powerful, 16 CPU, 32 CPU, and when an industry average was taken, it was not more than 5 to 10% of server utilization. Think like you have a big multi-story building and you are living into one or two rooms only, but still paying the maintenance, electricity cost for everything. So this was not right approach. It was not allowing you to utilize the full potential of a traditional server. Then came virtualization. In virtualization approach, the physical server remains same, but we replace the traditional operating system with a fine-tuned, very specific operating system, very spatial operating system that we refer as hypervisor. Companies like VMware, Microsoft Hyper-V, Oracle VM, these are the solutions which you could install on a physical server. And once this isolation layer is ready, you can start building virtual machines on top of it. Virtual machine can have their own operating system, and inside that operating system you can run your application. And once physical server can now host multiple virtual machines should not be a problem, and we will try to target around 70-80% utilization of this physical server. You can go further 100%, why not, but maybe it's better to keep some room for additional spikes into the utilization, or maybe a backup jobs run at the server level, or maybe a maintenance happens at the server level. Best would be to have additional capacity kept for it, but it is purely possible to completely 100% utilize the server. So what is a virtual machine? Virtual machine is a digital version of a physical computer. I would say it is a software-based computer, computer or a server which has hosted based into a software mechanism. And this virtual machine is running on what we refer as virtual hardware. We had this physical hardware. This hypervisor has created a virtual CPU, it has created virtual RAM, it has created virtual disk, it has created virtual network interface card, and that is how we are able to provide common resources which is required for my virtual machines to run. So all these resources have become a virtual interface or virtual devices. Once these virtual devices are ready, your machine would behave same like it is running on a physical server. So your operating system may not know that it is being provided with the resources in a virtual fashion or a physical fashion. It would behave the same, and if it is a standard operating system running on top of it, these virtual machine would also require maintenance such as updating, system monitoring. We would utilize these traditional tool to still monitor and maintain virtual machine. But idea is, like I give an example to explain virtualization is, if you have a piece of land, one option for you is you could build a house on top of it. Sorry for my bad drawing. So maybe on this piece of land, one house is built and one family would be living. But what if I could take the same piece of land and on top of it, I could build a multi-story building, a skyscraper? That would mean I would be able to have more families living inside, and that's exactly what virtualization is doing, using the same physical resource but logically isolating in such a way that multiple virtual machines can be running on top of it. So that is virtualization. So Amazon leverages this mechanism of virtualization, and the service they offer to run virtual servers into the cloud is called Amazon EC2, or it is short for Elastic Compute Cloud. Elastic word is you would see being used in multiple services. Elastic here is representing flexibility, like you could expand or shrink a elastic. Same way, these compute resources, or what we call instances, can also be shrink and can be expanded if the need be. We use a different wording for that. We call it scale up or scale down. We will discuss that in coming section. So this is a virtualization approach. What AWS is doing, AWS is following the same approach but with their own customization. Now, EC2 service was launched in 2006 and it has come a long way. And in this time, AWS has perfected that what kind of hardware software combination would well suit the running of the server, what component are critical, what kind of security is required, what kind of operating system should be there. So instead of taking a commercial server or commercial hypervisor software, they have built their own system, which is called Nitro. So chances are, if you are launching a new instance, it would be launched in a Nitro system. You do not see that directly, but it is basically a purpose-built hardware and software combination, which is proprietarily developed and run by AWS to run all these machines in as efficient way as possible. Right? So all unnecessary things maybe have cut down from the operating system level or software level, added security features to ensure that the data is safe, then maybe providing that maintenance can happen in a efficient fashion. So that will all be taken care by AWS, and the system they are running is basically called Nitro system. Once the system is ready, you do not have to maintain the system. It would be responsibility of AWS. But what you could do now on this system, you could launch something called instance. We used to call it virtual machine in traditional world, but now we started calling it Amazon EC2 instances. Sometimes people just call it EC2, or sometimes they call it a virtual server or virtual machine or instance, but basically it is a software implementation of a computer, and in that you would have operating system as expected, and that operating system would host applications on it. And yes, you can have more machines running on the same hardware. You do not control this thing here. You would be able to see only your instances which you have started in the environment. Right now, the wording we use is called provisioning an EC2 instance, or deploying an EC2 instance, or running an EC2 instance. That is instantiating a copy of a virtual server on which I would have an operating system and an application running. So service is Amazon EC2, and that service creates something called instances. This service has a regional endpoint, means the resources which you create stays within a region. This is a regional service. Even if I go further, you would see in some time that this is my region, and that region may have multiple availability zones like we have discussed before. Now, when you say I am going to launch an instance, that instance would be residing into one of the availability zones. So this is my AZA. The instance I have started would be started into a single availability zone. Instance can't be like this where it is using resources from two availability zone. That is not possible. You would have an instance which reside into one of the availability zone, and we'll see that in a minute. So yes, it is a regional service, but when actual instances are launched, they are launched within one availability zone. And AWS has made it very easy for you to build these machines. So I'll quickly go to console and we would create a EC2 instance. What my requirements are? My requirements are pretty simple. What I'm looking for, I am looking to create a Amazon EC2 instance on which I want a Linux operating system, and on top of Linux operating system, I want to host a small web server with a static page on that so that I could access it over internet and host my website on that. So that is my intention. Launch a Linux operating system based instance, have a web server installed on that, and get a static page running on top of it. Let's see how we can get started to fulfill this requirement. I am in services. I could look for different services, and here are my compute service option. You could see app runner, batch, and all. I am referencing EC2 right now, which is a virtual servers in the cloud. I'll go to that server. I am into Northern Virginia as a region as of now, and I would now start the process of launching an instance. Here we call it launching an instance. In your command line or in your API call, that is referred as something called run instance. So when you say I want to run an instance, basically it is still the same method of launching an instance. Currently, I do not have any instances running. I could see information here on my dashboard. I do not see anything. And if I go further down, I should have option to launch instances. And that's what I'm choosing here. I want to launch an instance. This is a pretty rudimentary way of launching an instance. I don't expect an enterprise environment you would be launching instance by this method. Probably you would have some automation, a script, or some infrastructure as a code tool who would launch instance for you. But we are at the early stage of learning. That's why we are using a management console to launch an instance. So I have initiated the wizard. This wizard would ask me some basic question, and based on that I would be able to get my instance running. So EC2, Amazon EC2 allow you to create virtual machine or instances that run on AWS cloud. Quickly get started by following the simple steps below. So as we have to give it a name like identification, so I could give it a name and let me call it my web server. This is my web server, and in that I would have a application and OS image selected. This is referred as something called Amazon Machine Image, or in short we call it AMI. This AMI is a template, so we don't want to waste time in going through Windows installation and then it will copy file. We would provide some detail, click next, click finish. We want to get started much faster. So what AWS has done, they have created commonly used machines template, Amazon Machine Images, and they contain commonly used operating system like you see here is what we refer as a quick start way of getting started. So in quick start, there are options available. I could select Amazon Linux, Mac OS to get started with Ubuntu, Windows, RHEL, SUSE, and some more common versions, common flavors of Linux-based operating system, which I could choose from quick start option. Now, quick start, as the name says, is to get you running quickly. But in case you want to have your own customization done, then you could look for browse more AMI and you have four options here. Quick start is what commonly use 47, and I am in Northern Virginia and that's why seeing 47. Maybe in a different region that number of AMI could be less. This is a generic operating system image which is given to me. If I have my own custom images, they would start showing me up here into my AMI. I do not have anything. And then there is a marketplace AMI, which is AWS and trusted third party AMIs. So a lot of vendors, they publish their software into a AMI format. Let's say I am looking for some business application to be deployed. I don't want to install it manually. I want WordPress certified by Bitnami and automatic. So I could just select that AMI and get started. So here is a list of different type of AMIs available in marketplace. These are certified by AWS, verified by AWS, I would say, and based on that, you would be able to launch things like I want to run Ethereum or OpenDex, or I want to run Bitcoin full node, and then you could see the pricing associated with that. We'll talk about pricing a little bit late, but idea is that instead of you wasting time or investing time into installing things, let's go ahead and utilize something which has already been available into marketplace. Then apart from marketplace, and I could see marketplace has so many AMIs available. I think it was 700 plus, sorry, 7,000 plus. And on top of it, there is another flavor of AMI which are called community AMIs. And community AMIs are a huge number. By default, it is filtering only 500, filtered 500, unfiltered. That's all is being displayed, but the total number of AMI could be huge. These are community, like you have Git repositories where people publish their code so that others can utilize it. Similarly, I may have created an operating system image for a specific purpose and I feel this can benefit others also. I would publish it into a community AMI. But community AMIs are not verified by AWS. So if you are using community AMI, my suggestion would be to do some basic sanity check in that for some antiviruses, some vulnerabilities, so that you would have a secure image to get started with. That is called community AMI, and then you can be very selective here what you are looking for. Let's say I'm looking only for Red Hat based, I could filter it and only those AMI would be displayed to me. So if there is a huge selection of available AMI, you could get started with that. Now, let's keep it simple as of now. I would go back to my quick start and I would say I want to use Amazon Linux. Amazon Linux is a customized version of Linux which Amazon has created to facilitate faster deployment. So that is displayed here, Amazon Linux AMI, and every AMI has a ID like you see here. So I'm happy to use this Amazon Linux 2 AMI. AMI number is this. Now one more thing, this AMI number is regional. So same name Amazon Linux 2 AMI in a different region would have a different AMI number altogether. The content of the image would be same, but the reference of the image would be a different name displayed here. Now, if you read here, there are two options. One is 64-bit x86 and then it says 64-bit ARM. What are these options? And I could have selected it here also. Let me explain what these things are. Let me go to Notepad. So 64-bit x86, whenever I refer, that is the CPU architecture which is supported by Intel and AMD. So when I'm launching a x86 based architecture, I would get a choice to select an Intel based CPU or a AMD based CPU. These are CPU manufacturers, vendors who build or create CPU, who produce CPUs. What is then 64-bit ARM? Amazon realized that it is better to build our own CPU so that we could cut down on the cost and give better performance, better price performance ratio to customer. So they have come up with their own processor, which is called Graviton. ARM, the base is the chip which you find in most of the mobile devices. So they have created their own chip and they call it Graviton. I guess this time the version of Graviton is 2, and that is allowing you to deploy a machine in a much price performance effective way. You could select it and get started. I would go ahead with the 64-bit ARM, and that would be a good thing to get started with. Right. So let me go back and I am selecting 64-bit ARM. Now, if this architecture is different, the Linux kernel or the base of the operating system would be different. That's why you could see that there is a different AMI for 64-bit architecture and there is a different AMI for your ARM based architecture. Your flavor of Linux is same, but the internal drivers and binaries or component will be based on what we have here. There are more details here like platform Amazon, root device type EBS, virtualization HVM, ENA enabled yes. I'll talk about them as we move forward, and let me just select this one. So I made one selection that I want to utilize Amazon EC2 machine with this Linux based operating system which is based on ARM, and now I would keep moving forward. So this is my architecture here. I'm not sure why it has not picked up, but let's go ahead and change that to a different architecture. So we selected the AMI, that is fine. Yeah, this is ARM now. Just it took time to refresh. The second thing we would be selecting to get started is called instance type. Let me go to slides and then I'll come back to what is an instance type, or better, like we read this information here. Select an instance type that meet your computing, memory, networking, or storage needs. What these instance types are, they are basically the characteristics of the server you are going to launch. So we talked about AMI. There are four ways to get an AMI quick start, my AMI marketplace. Now, when I say I want to have a specific instance type, I basically select that what ratio of CPU, memory, storage, or network performance is needed. For some application, it may be requiring more CPU. Some application may require more memory, some may require more storage or network. So there is flexibility. You could select something which suits your application need, and you don't have to like make this choice right now. You can start small, and then later once you realize that my application requires more CPU or memory, that time you could go ahead and replace the existing instance with the optimized instance for your workload. So you could decide on what works well for you. So here are my instance types. Instance type defines performance characteristic. They are optimized for different workload. I'll talk about details on that. And these are elastic, can be seen later. And this is region specific. As I said, it would be launched within a region in a availability zone. So these are different instance types available here. As you could see, this is a naming convention m5.d.extra large. Let me go to console again and show it to you there. So if I go ahead and select instance type, I would be able to select different instance type. It by default selected for me C6G dot medium, and that would give me one CPU, 2 GB of memory, and this is what the cost would be on a per hour basis. If I feel I'm okay with that, I could move forward, or I could say no, I want to compare instance types, and I would get a list of instances. And if you see, there are 606 instance types available depending on your use case. And there is a specific format of naming them, like this is C6G dot medium, one CPU. Then like you have shirt sizes, medium, large, extra large. Similarly, this one gives me one CPU and 2 GB of RAM. If I go from medium to large, I would get 2 CPU and 4 GB of RAM. And then extra large 4, 16 extra large, 64 CPU and 128. And I could have selected different type of instances to get started from here. So this is all the available options which I could have chosen to get started. These are different type, like this one says T4G dot extra large. Similarly, there may be more instances like G4DN dot 16 extra large. Now this one is not highlighted for me because this instance type is only available on x86 architecture, not on my ARM architecture which I have selected. Right. Let me explain what these naming conventions are. If you look here, the first letter tells you the instance family. The first letter basically tells that what type of performance characteristics or what is the optimization for this instance. Here, M is commonly misunderstood for memory optimized, but here the M represents something called multi-purpose. So this is a multi-purpose instance. This has a fair ratio of CPU and memory, and it is not very specifically designed for a very spatial workload, but it is multi-purpose, so it can work for most of the workload. You may find some instances listed as starting with C. C would represent a compute optimized instance, which would have more CPU compared to any other thing. CPU ratio would be higher. You can find instances starting with R, and they referred as memory optimized. I remember it by referring RAM, which is memory of the instance. So it would have more ratio of RAM compared to other entities. Similarly, you can find instances which starts with T. T stands for typical instances. People also refer, or it is also referred as something called burstable. I'll talk about burstable when the time comes. And then we may find different type of instances depending on our need. These are common ones, but there are more available, like there would be G, which will be having some graphic optimized instances on that. And I have provided a link here where you can find details of different instance type. So this is your M and T are general purpose. Then compute optimized would have C as a starting letter. Memory optimized will have R as a starting letter. Then storage optimized would have IM, IS, I3, D2, D3. So there are hundreds of instance type available. And the good part is you could change it anytime based on your requirement. Even you could automate it. So not somebody doesn't need to manually come and change something. You could automate the process of changing instance type. So you could select whatever works best for you. I am keeping it simple here and I am selecting the same instance type which has been provided to me. This is free tier eligible. That means that I won't be paying money if I use it on it. So I don't have to use this one. Let me go ahead and say C6G. I'm typing it here and then it will be giving me the CPU. Now this one is CPU C6G dot medium, large, extra large, 12, 4, 8. These are all the options. Metal is also there, but I would keep it to C6 dot large instance or C6 dot medium instance if I want to. Right. Now I would have some charges to pay. If you are not worried or if you don't want that, then best suggestion would be to go ahead and change it to something which is free tier eligible, and then you would be able to keep moving forward. So select whatever works well for you. How much money you would pay is displayed here, but there are other factor also decide how much money you would end up paying, and then you would select more setting related to key pair, network information, and then additional data like what type of storage you need on that, some additional information, how many instances you need, what type of server it is, and once you are ready, you could launch an instance. So this is a wizard in which you are able to go through and select the basic setting and get an instance started. Now I'm running out of time here, so I won't go with the whole discussion of how to customize the instance and how to run a web server on it. We will come back to that into the next section, but by this time you should have a better idea of what is an AMI and what is an instance type, and I'll speak to you into the next lecture where we'll complete the deployment of instance with a web server running in it. So enjoy your time. Talk to you soon. Thank you.